Hello, this is Aaron Maller from Parallax, and this will be a quick refresher video on a couple of tactics that we use for modeling roofs or floors with low slopes so that we can avoid the extra triangulation that happens when those items are sloped. As a reminder, some of this is also covered in the training video 6.03 for floors, because the opening subtractive method, which is what we call it, is used in both floors and roofs. First, we'll look at two different conditions on this roof that we may want to adjust. One of them is what we'll call a simple bay, where it's rectangular already and we simply want to slope down to a drain, but we want to avoid all of the extra triangulation lines. Then we'll come back and look at a more complex shape and how we recommend dealing with that. So to start, when you've got a basic simple bay and you want to slope down to a drain, here you may have added in slope defining lines, and then these 4 lines have been added as well. What I'm going to do to start is I'm going to raise this area back up to get rid of the extra what's called folding lines. So new in more recent versions of Revit, when they are black lines, they're called folding lines, and when they're blue lines, they're called split lines. There is a way to turn off the visibility of folding lines, but we don't want the roof to be sloped this way anyway. So the first thing we're going to do is I've evened out the slope, and again, we will drop it back down to 11 1/8 in a couple of minutes. All you need to do to fix the simple bays is you want to also draw in your diagonals as the split lines. So here I'm adding in our 4 diagonals, and by doing that, that will tell Revit where it wants to create those folds when we then select these lines and say to go down to 11.125 inches. And so you'll see now that this bay now is fixed, and if we were to put spot slopes on it, you'll see that they are all sloping down, just like this one. And the reason we don't want to just turn off the folding lines is Revit is actually calculating slopes differently on these planes, and that's what we want to avoid. So adding in split lines into your sketch before you lower and drawing in your diagonals will take care of this at the simple bays. When we get into the more complex bays, one of the tricks here is what we call the opening subtractive method. And the reason that we do this is if we isolate this roof for a second, if we were to use the spot elevation tool, you'll see that right now the exact same elevation is being used all the way around the parapet of this roof. That might not actually be the proper design intent. Of course, I'm making that assumption because I'm not working on the project. But typically, what we'll see is something more similar to this is sloping down towards the drain, which means that the elevation along this wall, if you will, is sloping down. It's not at a consistent elevation up here, which is what Revit has done now. And we're looking at this drawing in elevation, of course. So what we really want is the simplest slope where this ridge goes down to the drain, this ridge goes down to the drain, this ridge goes down to the drain, and what the slope is at, or what the elevation is at this edge and that edge as well, is what we call incidental. That's going to be a varying elevation based on the slope of these other things. So in order to do that, we use this approach that we call the opening subtractive method. This is something that a lot of civil engineers use when they're modeling grade. Essentially, what we're going to do is first, I'm going to again raise our low point so that all of the extra folding lines go away, just as a starting point. And I misclicked that, so we're going to do it again. And I was hoping that was going to get rid of, oh, it did not do it. So let's grab all the lines and let's change their elevation to be that. There we go. So we've gotten rid of the lines. I'm also going to go back in and I'm going to get rid of those extra lines that we said to make on the simple bays. Now, again, this one is a little non-standard because I do also question this drain being this close to the ridge. That's going to be a pretty extreme slope right there. But again, I'm going to table that for now since I'm not actually involved in the project. The opening subtractive method starts out by saying the first thing we want to do is go all the way back to the floor sketch, and we want to simplify the sketch in this area into the most basic shape that can achieve the slope that we want. So right now, I've simplified this bay into just a rectangle. And now what we're going to do is we're going to again check that our slopes are all proper, and they were all supposed to be at 1 foot 2 1/8. So I'm just going to correct a little of this to get us back to where we want to start. And I'll check this as well. Okay, so I feel like that did not yet correct, whoops, what I wanted. Let's just do all this. If we do all of that together, they should be 1 foot 2 1/8. There we go. Okay, now order of operations is, because we want this edge to be the incidental or the implied edge, I'm going to do the same tactic that we did on the other bay, which is first I'm going to draw my diagonals to get the slope that I want. And I'll show you why this method is great as soon as we're done. And now I'm going to lower this to be the 11.125 inches so that now everything is sloped correctly. And if we were to look at the spot elevation here, you would see that now it is properly running down, if you will, while it's sloping in that direction. Then we're going to go to the architecture ribbon and use what's called a vertical opening, and we're going to select that roof, and now you can quite literally shear off everything that we don't need in the roof. So if I go around the parapet like so, and keep in mind, depending on how intense your custom shape is, you may have to use several vertical openings. You can't like trace a giant donut around the whole building. It generally won't let you do that. But if we remove that now, while this may not be 100% the design intent, if we were to start checking our spot slope, you would see that everything is now sloping in the correct directions. And if we were to go and check spot elevations along the roof, you would see that that's now sloping down. And then, of course, that's consistent at that edge. And then this starts sloping back up. The nice thing about this approach, again, is Revit is going to respect the order of operations that was done in. So later, if you decide, okay, this actually needs to move over here, you'll see that we're actually moving that and we're maintaining the order of operations here. So again, I'm just experimenting with different locations for this. Hopefully you'll be a little more accurate in terms of moving it. Now, because of how aggressive some of the custom shapes are, you may decide that it's easier to deal with like that roof as one roof object. So maybe you do the custom shape for this thing, you know, and kind of figure that one out on its own, and then you have this be a separate roof. I think it's okay to do these as different roofs. I don't know that the entire building needs to be in one large roof. That sometimes can help with the complexity, just because when you start adding in the openings and wanting to, again, so now here's a different situation. We've got a drain basin here and a drain basin here. So I'm looking at, you know, should the ridge be here, or should it be here, or should it be here? Because right now we don't have one really in between these drains. So I would definitely want to kind of compartmentalize this. And that's where, just if it's me working on the roof design, I may break this roof right across that if there's going to be a ridge there, or if it's going to be at one of these locations, you may break it just to make modeling it simpler. But having said that, basically, I would go with add split lines and always draw in your diagonal valleys or ridges, because that will just make things work a lot better. And then go with what we call the opening subtractive method, where you actually simplify the shape, draw what you need to accomplish, and then use the vertical openings to shear off the remainder of your floor or roof objects. Then again, and just to be clear, I would not recommend this next part as a solution. I would do this after the fact. But if you do go down to roofs in recent versions of Revit, I was expecting... It looks like maybe I'm wrong and they only did it for floors. I thought they had done, they had done folding lines and split lines. I am incorrect, and that happened only for floor objects, so you won't be able to turn them off just for the roofs. But it's okay, because if you do these correctly, you will have a much more cleaned up series of lines. So, by the way, for this demo, I threw in some walls. Obviously, I have no idea if there's really walls around this roof, so if you have any other questions about the specifics that you may need to do, let me know. And you can do the same thing, by the way, with the vertical, the opening subtractive method. You can also remove this portion of the sketch. So again, I don't really know what the design intent is here, but just as an example, if it's me, I probably delete that from the sketch, which is going to change this roof quite a bit. And now when I go into modify subelements, since there is a drain here and a drain here, I'm going to assume that there's something running across here that's going to be our ridge. So I'm going to put that in, and keep in mind I'm doing this totally off the cuff because I don't know anything about this project. So if we do that, and now I'm just simplifying my sketch because we have some weirdness going on. And then what I'm going to do is, again, I'm going to say that all of this should be at the higher elevation until I get it resolved. So we're going to go back to 1 foot 2 1/8, which is going to simplify everything. Okay, now this bay is already pretty simple, but it does have that one point there, which may make it a little more complicated after the fact. So that one I'm actually going to leave, again, having some questions just about what this all looks like. So if we go in and we say, let's add a split line, and we'll put one in here, we'll put one in there, we'll put one in here, and we'll put one in here. Now we are going to end up with an extra line right there. And this is, again, where if you really wanted to fix this, what you could do is you would probably first need a detail line. And again, I don't know that this is the design intent, so I'm going to just draw this, but it's, the fact that this roof would be kind of arcing out here or turning at this angle. We could, in theory, just extend this angled line out and have the elevation at this wall be tapered. So if we wanted to do that, and I'm not saying that we need to, but we could basically break this thing like that and then shear it off after the fact. And I'm only doing that because I'm not sure what's happening with this roof. So if we do that, maybe when I'm doing this live, I don't pay proper attention to what I'm drawing. So if we were to do that, then in theory, we could go back in here and say, again, there's going to be a split line here. And we have to add this one in because it's new, right? So we've also tweaked this a little bit, and that's because I deleted that. So if I wanted to fix this properly, that just healed that side, which is nice. So now I could put this in here as well, like so. Okay, so then, again, if this was all at 1 foot 2 1/8, and I did lose my other ridge line that I had drawn earlier, so let's add that back in, like so. So I'm going diagonal to this, just trying to create basic planes for where I think the roof slope may go, right? So in this case, if that's all at 1 foot 2 1/8, and that's at 1 foot 2 1/8, and that's at 1 foot 2 1/8. Okay, let's try that again. Sometimes it's tough to grab everything and you don't have to raise it back up if you're doing this at the beginning, but just because I'm working on a roof that's already in progress, that's easier to do it that way. So now let's say, and again, maybe this line was, straight. Maybe you drew it better than I did. So if you have it straight, so much the better for it. But again, let's just approximate like that. Okay, so now what I may do is I may, again, drop these down to the 11.125 inches. We're still going to get our funky lines here. That's annoying, and we don't really want them there. I don't know that I drew that perfectly straight. And again, if I really wanted to resolve that, I could do this with a simplified shape by making the roof like this and then carving all that out. I didn't do that though, but in this particular case, we're now at least a little closer in terms of what we want this to be. And I feel like that point will go away if this roof gets kind of reconciled to, maybe have this ridge follow that line, depending on what you guys are actually doing here. So I'm going to ignore these for right now, just to get back to the rest of this kind of demo. So up here again, we would probably want to simplify this into whatever the actual shape was going to be, the max slope shape, if you will. And so looking at this thing, and I'm going to just kind of go off the cuff because I'm not really sure what the design is. But so if I take all of these and put them back at 1 foot 2 1/8, that should simplify. Well, I guess I don't need to do this quite yet because I'm going to need to edit this shape as well. So I want to simplify this again into our most basic shape. So I'm going to take that thing and I'm going to take that thing. And it is quite possible that what I do here is this thing actually just needs to move out so that we are encapsulating the maximum shape of the roof. So this is where, like I said, we will draw these things to a bigger shape than we need, and then we will carve them away after we've sloped this. So there we go. And now again, I'm going to reset these to our max height. There we go. Okay, and now I'm going to go back in. I'm going to add my split line. And again, I'm assuming where we want these things to be. You could definitely reposition these split lines and these points where you may want them. So if we do this as well, all the way to the corners of where we think the planes would be, and then drop this to our 11.125. And I'm just using the values that were in here before, right? Oh, and so again, I meant to simplify that, and I didn't because I wasn't paying attention. It's hard to talk and do this at the same time, but if we had a detail line there, and we said that we were going to align that to there. So again, just creating a more simple shape so that it does that, and now we would have to add in the line that disappeared because I just moved the sketch. So we'll do that, and then we'll raise this back up to fix it. And then we'll add in our new split line here. So this is like the approach for now we lower this. And again, I think we're going to end up with one extra line there. But again, I'm not sure about the actual design of what this shape is. So just to show you now, we can go back with our vertical opening, and we can first shear off everything that we don't need over here, right? So if I take all this, and this is where it might not let you do all of this in one sketch, but if it does, that's cool. So we'll give it a try. And when you go to do that, you will want to align that just so that it's... We'll see if it'll let us rip that off at once. Oops, I guess I do have to sketch properly. Okay, so that one it says is too big. This does happen sometimes. So in that case, then what you do is just convert it into two different openings. It sometimes doesn't like going around corners or where there's like coplanar surfaces. So it lets us do that one, and then you just have to do another one down here. And it's probably just because of the complexity of the corner, it says that's not okay. So if we do that, we're probably going to be fine. There we go. Okay. And then again, you can do the vertical opening on this shape here. And what's nice about this is we know that the roof really wants to be its slope wants to be kind of independent of what's happening if this is a stair tower or whatever else. So the slope wants to be sloping away and sloping away. And now if we go back and look at our spot slope, we have that happening. We're just going around the roof in this case. So this is how I would approach it. And again, because of the particular shape of this building, there are a couple of additional lines here. If I knew more about the actual design intent, I would draw this out with detail lines first to get it more exact so that we didn't have these extra points. Like this point here, I don't think would really exist. Or at least if it did, then we would have this thing coming across. Maybe this is really how it would be done. But we could definitely tweak it to iron out a few of these little idiosyncrasies if I just knew more about the design. So these are the techniques that we use for simplifying roof modeling and making sure that it is all modeled properly without getting all the extra triangulation lines in there. So if you have questions or if you want to go through this again on a live job, just give us a shout.